Okay, so let's start from the beginning. A student investigates the extensions of a spring and uses it to determine the weight of a meter rule. Okay, so you see this is the initial length, the natural length of the spring. Then you hang a 1.0 Newton load below of it. Then it is extended. The spring is shown full size in figure 1.1 and figure 1.2. So when I say full size, that means you can measure with your ruler. Figure 1.1 shows the spring without any load. Figure 1.2 shows the spring with a load of 1.0 Newton suspended from it. On figure 1.1, measure length L0 of the spring without any load. Okay, so of course we can measure with our ruler. Okay, so of course here you don't print out the paper, right? So it depends very much on what device you are using. Okay, so if you are using handphone, then it will be very small, right? So this should be 2.0 cm. Imagine that you have a piece of paper.
So what about 1.4?
1.4. It is 2.0 actually. Okay. Yeah, 2.0. Okay. So 2.0 cm. Now for the other one, the LS. So for this, again, I have to say that in actual exam, you will have the exam paper. So you can just use your ruler to measure it straight away. Remember to bring a ruler. Must bring protractor also. Sometimes you need to measure angle. If you still remember the resultant vectors and all those, we need angle. So 6.2 cm for this. Okay. Now we look at B. The student attaches a meter rule to the spring with a wire hook as shown in figure 1.3. Okay, so you see the figure 1.3, the spring is here. Attach a meter rule to the spring with a wire hook. So this is a wire hook. This is the meter rule. Okay, then the scale of the meter rule faces upwards. Okay, so the scale you can read on top of the meter rule. She ensured that the meter rule is horizontal and briefly describe how to check that the rule is horizontal. You may draw a diagram if it helps to explain your answer. Okay, so to make sure it is horizontal, so you can just do many ways. One of the easier way is you measure. You measure the distance from bench at each end and check whether they are equal or not. So that means you measure the length here and you measure the length here. So if they are same, that means it is horizontal. Okay, so I write down, measure the, okay, measure the height of the meter rule at each end and make sure they are equal. Okay, then we look at C. The student moved load W to distances D equal to 20 cm, 30.0 cm, 40.0 cm, and 50.0 cm, and 60.0 cm from the pivot. So you can see here, this is the pivot. So move the load to different distance. Of course, the idea is if you move more to the right, then you should expect here to go down more, okay, because of the load. Now, she reads the length L of the spring for each values of D. The reading are shown in the table. So the more you move to the right, the string is longer. Use the values from table 1.1. Plot a graph of L against D. Start the axis at the origin. Okay, so we just need to sketch the graph. Okay, now let's put the scale first. So the x-axis is D. So D is simple, 20, 60. Yeah? So we just do 10 by 10 then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here will be 10, 20, 30, 40, 50, 60. Okay, then we draw a line. And label this as D, cm. Okay, now for the y-axis, we use length L. The longest is 9.0. So we can just take 1 to 9. Okay, let's see first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so in that situations, I can use 2, 4, 6, 8. Okay, let's say I do until 9 only. Okay, so in that case, I have to cut by half. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 5, 7, 9. Okay, so that is going to be LCM. Okay, now we mark the point 20.0, 6.2, 6.2, one box above 6, 30.0, 7.1, 7.1, half box above 7, 7.6 for 40, 7.6, 2, 4, 6, 8.3, 2, 3, okay, then 69.0, 9.0, 1, 2, 1, 2, 3, 4, 5. Okay, so we get this. Then after that, after you plot the graph, of course, we need to join up with the line of best fit. So from your graph, determine L. the value of L when D equal to 0. Okay, so like what I said, we have to draw a line of best fit. So we try to passes through as many points as possible. So let's see first. Is it possible for me to have a ruler on it? So let's see. Okay, so something like this. And now, from your graph, determine L, the values of L where D equal to 0, 0.0. So you can read here 5.0, 5.0 cm. Okay, then after that, let's continue. 5.0 cm. Let's see first. Calculate VWR, the weight of the meter rule, using your values of L from C part 2, the values of L0 and LS from A, and the equation given here, where K equal to 1.0. So they give you a formula where you don't know what kind of formula is this, but it doesn't really matter. You just need to substitute with values. So remember that our L0 is 2.0, our LS is 6.2. Okay, so L0, 2.0, LS, 6.2, L is 5.0. Okay, we substitute. So WR 2, 5.0, 2.0, 6.2, 2.0, multiply with 1.0. Then we just press calculator. 2 times 3 over 4.2. So what I get here is 1.43. 1.43. Okay, so 1.43. And you have to put the unit. Must put unit. Without unit, you get 0 marks. So how to form the unit, or how to find out the unit? So you imagine in this way. Length minus with length. Imagine 5 meter minus 2 meter. At the end, you still get. Oh no, this is not meter. This is cm. So 5 cm minus 2 cm is 3 cm. So imagine you have 2 times 3 cm. The bottom is 6.2 cm minus 2.0 cm. This minus this, 4.2 cm. Times K. K is 1.0 Newton. If you include unit, it will help us to finalize the unit. So imagine a cm can cancel off. So what remains is Newton, So at the end, it should be taking the unit of Newton. Okay, so that is how we determine the final unit. You just put the calculation together with unit. Whatever you can cancel off, just cancel it. Whatever left at the end, that will be the units of this thing. Now, D part 1. It is sometimes difficult to position the load W on the scale of the meter rule at the correct distance D from the pivot. suggest one change to the apparatus to overcome this difficulty. Okay, so that means position the load W on the scale of the meter rule. You see, what happened is you want to put the load on the meter rule. Sometimes it's a bit hard because you see this is, when you put here more, then the spring is extended, and then the ruler is like going down a little bit, and you want to put a load on the meter, maybe it slide down now. So to avoid that, you have to suggest a suitable way. Okay, so for example, you can suspend load from loop of thread. You use thread to hold the load, avoid it from sliding. Or maybe you can put some plasticine, a little bit of plasticine or cellophane tape to hold it. That's fine also. Part 2, suggest one possible source of inaccuracy other than the difficulty described in D part 1. Assume that the experiment is carried out carefully. Okay, so one possible source of inaccuracy. So for example, you're using meter rule. Maybe your meter rule, the scale is not uniformly distributed. So meter rule not uniform. Okay, so the other possible answer, if you feel, oh, I can't think of this, then you may use spring extension is not linear. Maybe you feel, oh, I can't think of this also. One more options. The load, the load that you use, right? Based on the questions, it has to be 1.0 Newton. 1.0 Newton. So it will be easier to say that the load is not exactly 1.0 Newton. This will be the easier answer. You're supposed to put 1.0 Newton on the spring, but maybe the load is not exactly 1.0 Newton, and then it causes inaccuracy. So this is easier point, the last point.